Okay, so yesterday we did one of these three things. Hopefully we'll get through the other two today. I think we should. All right, so what did we do yesterday? Area of what? Yeah, we did area of a rectangle, and let's just do a little recall here. Area, we'll put a little R right there. What's the area of a rectangle? Yeah, length times what? Width. Okay, that's how, when you're a kid, when you first learn how to do area, that's usually how they do it. You could say length and then a dot. You could just go LW, put equals here, right? It means the same thing, agreed? Okay, what's another way that we said we could do this? Instead of length and width, what are the other two words? Yeah, base and height, okay? So base times height. So any of those would be fine, okay? You're probably used to saying length times width, but you can also say base times height. Now, what has to be true? We're going to talk about this a little bit more today. What has to be true about the base and the height to each other? No, not the same measurements. If it was a square, they'd be the same measurements.
No,
Same units?
Yes.
Well, it's true. In order to multiply them, they would have to be the same units, okay? So you're not going to multiply something that's 2 feet by 7 inches and get 14 anything, right? You got to change one to the other. But we're not going to do that today. I don't even think we're going to do it all chapter, I don't think. But what has to be true about the base and the height? It's the last thing we talked about, I think, yesterday. If you have a rectangle, what do we know about the rectangle? It's a what? Well, it is a parallelogram, but it's a 90-degree angle, right? Specifically about being a rectangle, right? So if you call this the base and this the height, what must be true about the base and the height? They must be what? Perpendicular to each other, okay? That was the last thing we talked about. So they got to be perpendicular. So that leads us into this next thing. So rectangles, parallelograms, then triangles. It seems like normally, I don't know, whenever I taught out my geometry in the past, before I used this book, they would go rectangles right to triangles, and then they would do the other stuff. But that's fine. It's no big deal. We'll just do... I'll show you once we get to triangles, and it'll kind of make sense. But let's do a parallelogram. So let's draw one first. Right? We've talked a bunch about parallelograms in the past. Let's see. Transform. Let's change this to like 20 degrees. There we go. Now that kind of looks more like a regular parallelogram. Would you agree? If there is something that's called the parallelogram. I'll tell you right now that the area of a parallelogram, I'll put A and then a P right there, P for parallelogram, is actually the same exact thing. But we're not going to use length and width this time, okay? We're going to kind of get away from the length times width. What did I say we're going to use? We just talked about it. Base and height. So the area of a parallelogram is exactly the same equation. Like, well, why would you even put that in there, okay? But I'll show you something. We just finished talking about it, and that's why I talked about it. What must be true about the base and the height? They must be perpendicular to each other, okay? So, could I, now don't write this part down, okay? Everything here you can write down, but this next thing I'm going to write, don't write. Everybody with me? If that's the base, could I call that slanted one the height? Why not? Well, it's tilted, but more than that, it's not what? It's not perpendicular to the base. That's right. So this could not be considered the height. Now, you could draw this. Okay, you can put base here, and that's fine. So I can call this the base. Where would the height be? Straight? Perpendicular. That's the word I want to hear. I want to hear perpendicular. Okay, everybody says that. And every time they say it, I always say what? Don't say straight down or straight up. Say what? Perpendicular. Okay, but still, people still say straight up and down. You could take any point along this side right here of this parallelogram, any point, doesn't matter. And then as long as it's what? Perpendicular to the base, we could consider that to be what? The height. But we don't usually pick some random point in there. Normally, we pick a point either here, right, where they come together, or what? Here. I would not pick this one. You could, but what would I have to do if I pick this one? I'd have to come here, and then I'd have to extend that out a little bit. That's a pain, isn't it? So which one am I going to pick? Probably this one right here. All three of those lines that I just drew are all the same height, aren't they? The same distance, the same length, all right? So that would be the height. As long as it's what? Perpendicular to the base, all right? So if the base and the height are perpendicular to each other, we could consider that to be the height. So that's really, really important.
So would you still, like, let's say that the base is like 5 and the height is like 2, would you still just...
Absolutely. Yes, exactly. Good point. Well, you wouldn't. Did you say divide by 2?
No.
Multiply, okay. So would you say 5 and 2?
Mm-hmm.
Yeah. As long as I know that's 2. Now, we're not talking about that one. That's not 2. Okay? But if the, I hate to say this, but so that you remember, the one that goes straight up and down, all right? Or the one that's what? Perpendicular, okay? That's a better way to say it. Okay, the perpendicular lines. Now look, the 5 doesn't just cover from here to here. It's the whole entire thing. Everybody see that? All right, it's from here all the way to there. That's the 5, all right? And then from here to here is the 2. And yeah, absolutely, the area is just what? 5 times 2. And that would be 10 whatever it is, okay? If it was inches, it'd be inches what? Squared, okay?
So would that be the area of the whole thing?
It would be the area of this whole thing.
So what it would just be from the red mark?
Nope, it's the whole entire parallelogram, okay? Everybody see that? So the whole entire parallelogram, that would be the area. It would be 10. So I could fit 10 squares in here. Now it'd be kind of hard, wouldn't it, to break this up into all squares, but it's what it would be, okay? If you could fit them all in there, slant them or do whatever you needed to, you would get 10 square inches, right, in there. 10 squares that are 1 inch by 1 inch to fit inside of there. You with me on that? Yeah, it's pretty easy, isn't it? As long as you recognize what? The base and the height are perpendicular, okay? I was doing this earlier, but I didn't do it, so let's just do it right now. You could also, I'll just do it right here. You could also pick that as the height, couldn't you? You could pick this one as the height. You could pick anywhere between here and here as long as they're perpendicular, right? If you go from the top of one perpendicular to the bottom of the other, okay, that would be the height. You could also pick this one. But again, what did I say you would have to do to the bottom? Extend it. Good. That's what I was looking for. You could go from the bottom to the top and extend that little bit right there too. Right. You could. What did you mean? Come up there and point to it. No, because that's not the height of the whole entire thing. Okay, you got to go from the base, and the height has to go, I guess, opposite sides from base to base. Okay, yeah, because on a parallelogram, this is considered the bases. All right, so yeah, so from here to here would not be the height because you don't know where to go. I mean, look, if you did the height from there to there, well, that would be a different height, wouldn't it? That would be a different height. But look at the red ones; they're all the same height, aren't they? All right, so you have to go from the top to the bottom, perpendicular. We good? All right. Let's see. Now, remember, you guys always want to say straight down. Well, not every base. I'll tell you what. Let's do this. Let's just redraw it. I was going to try to use this one and recycle it, but let's draw it like this. And let's slant it a little bit. Oh, wrong slant. Let's slant it the other way. There we go. That looks a little bit like I have in my notes. I guess it's in the book as well. Let's just bring this up a little bit. Make it look a little bit more like in the book. That's pretty close. All right, everybody with me? Here's what they give you. They tell you that that's 25. And they tell you that that is 13. Now, to find the area of this, do I just go 25 times 13? No, because what's not true about this? They're not perpendicular, are they? So I can't just go 25 times 13. But they do give you another tell you what, let's just do it different. They use a dotted line. I'm just going to use a color line. So let's make this, does that look perpendicular? About right there. That looks a little better, doesn't it? Yeah, it's good enough. All right, so let's say that. And they tell you that that is 10. And they're all inches, 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 okay? And they ask you to find the area. Find the area. I'll put equals question mark. Is that all right? So how do you find the area of a parallelogram? You go what? The base times the height. But what has to be true about the base and the height? I've said it a bunch of times already. They got to be perpendicular. So which two numbers are your base and your height? Which one? 25 and 10? Yes. Because if this is 25, then what? That's 25, right? From this whole thing is 25. See, they're the ones that are perpendicular, correct? All right, so remember how I said I didn't like you saying straight down or straight up? Do you see how that's not straight up or straight down? But it is what? Perpendicular, okay? You understand now why I'm trying to be a little picky on that, okay? So, yeah, so that length right there is 25 because it's a parallelogram and opposite sides are equal to each other. All right, so if that's 25, that's 25. This is your base. I'm sorry. This right here would be your height. And again, it really doesn't matter which one you call the height, which one you call the base, because all we're doing is just multiplying the two together anyway. That would be the height. What would you call this one then? This would be called the base. All right, so you got that whole thing is 25. You got this is perpendicular to it. It goes from one side to the other at a 90-degree angle. Those are your two numbers. So you just multiply them together. 25 inches times what? 10 inches. Now they do give you units on here. Every once in a while they may not do that. They might just put numbers in there. So you don't have to put the units. But when they give you units, you have to put the units in there. So what is it? 250? And then what? Just inches? Inches squared. Area is always squared. Because it's how many... Call the doctor. Because it's how many squares can you fit inside that thing, right? And that's why it's square inches. Pretty easy, right? All right, let's do another one. Well, not another parallelogram. That's enough of parallelogram. What do you think we're going to do now? Triangles. That's right. So let's just write. I didn't write down parallelogram before, but let's write down triangles. Samar, you asked me about why would you go from rectangles to triangles, didn't you? Good question. I want to show you something. Let me just show you how they come up with the equation. All right, this is a rectangle. You got it. So this right here is a rectangle. So if I call this the base, I would call that the height, correct? Now, what if I wanted to make that into a triangle? Then watch what I could do. If I went from one corner to the other, look what I just did. What did I do? I made not just one triangle, but what? Two triangles. So what do you think? Now remember, the area of the rectangle is the base times the height, correct? So what do you think the area of the triangle is going to be? Watch. Let's just take this triangle right here. And what do you think is true about these two triangles? They're what? They're going to be congruent to each other, aren't they? All right. So what if I just wanted to find this? Say, Tanisha, you said it already. Right. It's base times height, what? Divided by 2. Okay. And that is the equation or the formula, whatever you want to call it, for the area of a triangle. Why? Because the triangle is half the what? The rectangle. Does it make sense on where you got that from? A lot of times when you're a kid, you see it like this. Area of a triangle is 1/2 the base times the height. That might be how you memorized it, all right? But isn't that the same thing? Just the base times height divided by 2? Yeah, you can look at it either way. It doesn't make any difference. It's the same exact thing, all right? I just like this because you saw base times height is the whole rectangle divided by 2 because there's 2 equal triangles in here, and that's the area of the triangle. It's also the area of this triangle up here. Make sense? Yeah. Well, You know how we did that base height thing and they got to be perpendicular? It's going to happen here as well. So by the way, if that's the height, this is the height. And so are the base and the height perpendicular in this particular situation when you have a rectangle? Yeah, because it started off as a rectangle, so you know that's a right triangle, and you're good to go. Let me draw a couple other types of triangles. Let's just do a regular looking acute triangle. Let's just do it like, kind of looks like a right angle, but it's not. It's a little less than 90 degrees. All right, if I call this the base right here, where would the height be? Is it this side of the triangle? Is that the height? Is it this one right here? No, because neither one of those are what to the base? Perpendicular. So what would the height of this triangle be? From the top, where? You're whispering, I can't hear you. Okay, the very top, where? Perpendicular, very good. I was waiting for somebody to say straight down. All right, but you guys are learning, that's good. Perpendicular to the base. So that right there, that red one, would be the height. So just make sure you're careful on which one. If you consider one of these to be the base, the height has to be perpendicular to the base. Like what if you I'm not going to draw it on here, but what if you consider this one to be the base? This left side right here. Where would the... Yeah, it'd go from here perpendicular to here. That would be the height. Make sense? All right, so you can make any of these the base. It doesn't have to be just the one that's on the bottom that looks flat, okay? Doesn't always have to be that. Okay, that could be the base. This one could be the base, but where would the height be? The height would be from this perpendicular to the base. Make sense? Okay, let's do another one. So it's an acute triangle. What's another kind of triangle we could draw? Actually, an obtuse, yeah. Tell you what, let's push this up a little bit out of the way. And now, let's draw an obtuse triangle. Oops. There we go. And there you go. All right. Just like the other one, if I consider this to be the base, we kind of already touched on this earlier, all right, when we did the parallelogram. If I consider this to be the base, where would the height be? Now this is a little bit weirder. So if this is the base, we're going to start from the top up here, aren't we? Where are we going to go? We're going to go to there? Is that the height? Is that the height? Is somewhere in between the height? No, you got to go what? What do you have to do to that side B? Extend it, right, until wherever it hits. I'm not sure exactly where it hits, probably about right there. Okay. Let's go ahead. Well, if I consider this to be the base, you could not. If this is the base, okay, it would have to start from here and go perpendicular to this, okay, if I considered that to be the base. I don't have to make that the base. That could have been the base. This could have been the base. But I decided to make this one the base, so where's the height? I got to extend that side, don't I? Like this. And right there, that would be the height. Even though it's not part of your triangle. It's completely outside the triangle, isn't it? But it's still the height of the triangle. Okay, it's from the top, perpendicular to the bottom, if you want to call it, if you want to say that. Okay, it's from the top, perpendicular to the base. We good? All right. Well, we've already done this one, but I'll do it again. I got it in my notes. This one's the easy one. What if you had a right triangle? All right. And I call this the base. Again, it's already a right triangle, so I already got that right there. So it's pretty obvious, isn't it? Which one is the height? Which one is the height? This slanty one or this one on the left? One on the left. That would have to be the height. Why? Because they are perpendicular to each other. Have we said that enough? Perpendicular to each other? Yeah, I think we have. All right, let's do an example and we'll be done. How about that? When's this over? 28. 20. Oh, I got lots of, yeah, I got plenty of time. All right, so let's do an example. This is super easy. It's another acute triangle. So I'm going to go to here. I'm going to go to here. and to here. All right. So this is kind of something you might see on your homework, see on the quiz, test, whatever. And they tell you that's 12. You draw a dotted line. Obviously on a test or a quiz, it's not going to be a colored line. So I'll draw a dotted line right there. And that's the height. Now, this is a little bit trickier, okay? They're not just giving you the base and the height. Anybody could take the two numbers and multiply them together. Would you agree? Even if they're real big numbers, you can always use a calculator, all right? So they can always give you two numbers. You multiply them together, then take what? Half of it, right? Because it's a triangle. Make sure you remember that. All right, so, but what if they do this? What if they actually tell you the area? All right, they tell you the area is 54 square feet. And what do you think they're asking for? The height, right. So they want you to find the height. It is, but let's do the formula. It's not quite. Okay, let's do the formula. So what's the area? I'll put a little t right there. Area of the triangle. It's what? It's the base times the height divided by 2. All right, so I start off with our little formula. And now let's put some stuff in here that we know. What do I know? I know the area, don't I? What is the area? 54, so I put a 54 in here. Do I know the base? Yes, I know the base. What is it? It's 12. Do I know the height? Nope, so I just keep it h. That's my variable. But then what do I have to do to that? Divide it by what? 2. Can you do some algebra and solve for h? Yeah, it's really simple. What's 12 divided by 2? 6. How do I get rid of that 6 if it's 6 times h? So let's rewrite it. 54 equals 6h. How do I get rid of the 6? Multiply? Divide by 6, right. Okay? You're thinking too hard. It's a lot easier than that. Divide by 6. Divide by what? 6. And what's that? What's h? 54 divided by 6. 9, right. 9 sixes are 54. Remember that? Okay? And there you go. Now, we don't just leave it like that and circle it, because they told you this is feet squared. So that must mean this is 12 what? Feet. Should have put that in there. Okay, they tell you that it's feet. So what is the height? It's not just 9. What is it? 9 feet. So make sure you put the units in there. All right, and there's your answer. Does it work? What's that? Doesn't work? 9 times 12 is, what is that? 108, right? You know your 12 tables? Okay, 9 times 12 is 108, but that's not 108. Yeah, but it's a triangle. So what do we do to it? 108 and what? Divided by 2. What's 108 divided by 2? It's 54. It does work, doesn't it? Make sense? Yeah, really easy. I know I say that a lot on a lot of things, but this is true, isn't it? Yeah, at least this time. It looks like I split this. Did I do that on the lesson plans? Do I split it into an A and a B? Yeah. Yeah, so we're still on track, right? So we'll stick with what I wrote in the lesson plans. So let me write it down here. So it's section 7.1a, and it's pages 301 to 302, and it's numbers 1 to 19. That's A. All right, B is 24 to 31. 24 to 31. But we'll separate it into 2 assignments. So I'm not going to teach anything new tomorrow. I'll just let you work on the second one in class. And then tomorrow, or Friday, we will do 7.2. All right? I guess I could have given you all, but 1 to 31, that'd be a lot. Well, you don't have to do 20 to 23. So anyway, I'm still going to keep it like that. Yes, you can take a picture of the book. If you don't want to take the book home, just look on your phone. I have no problem with you doing that. All right, so that's 7.1b. That'll be tomorrow, though. All right, I'll let you probably work on this in class. We'll go over this together in class. Then I'll let you work on this in class. Then hopefully tomorrow you won't have any homework because you'll have everything done. Okay? Everybody good? All right.